Algebra students, Mr. Lawrence here with your next flipped lesson, and today we are going to examine patterns and what I call the nth term. Now, I know that some of this is going to be reviewed for you because you've all seen problems like this where you had to come up with the next three numbers in the sequence, right? Okay, now to me, that is way below your ability. You guys are so smart. My pre-algebra kids can do this once they know the way to do it. We're not just going to find the next three terms. We're going to come up with a way to find any term. I don't care if they want the 75th term. I mean, I know all of you can go, well, hey, this will be 18, and this will be 21, and that'll be 24. Okay, well, what term is the 24? It's 1, 2, 3, 4, 5, 6, 7, 8. It's only the 8th term in the sequence. If they asked you for the 75th term, you'd have to make an awful lot more blanks and fill them in. Or count in your head or something like that. Make a mistake, get it wrong. We're going to come up with a way to create a formula or find the nth term, and we'll use that formula to tell us what the 75th term is, or the 20th term, or the 90th term, whatever the case may be. But first, before we do that, I have a couple simple questions to ask you, because most higher level mathematics is very simple. It builds on the most basic of things, and then just takes it very deep. What number comes after 5? Well, 6. How'd you get there? You add 1, right? What number comes after 33? Well, 34, right? How'd you get there? Well, I add 1. What number comes after 1,172? 1,173. How'd you get there? I added 1. Now remember, in math, we use letters not for letters of the alphabet, but to represent unknown numbers. We call them variables, right? So remember these three baby step examples and see if you can answer this question. What number comes after n? If you're thinking, oh, you're not thinking like an algebra student, I just got done saying that we don't think of letters of the alphabet. We think of them as an unknown number. Excuse me. So let's go back and see here. If n were 5, 6 would be the next number. How would I get there? I'd add 1. N could be 33, then the next number would be 34, right? So I'd add 1. If I want 1,172, the next one would be 1,173. Now some of you are thinking, well, wait a minute. If we don't know what n is, how can we know what the next number is? Well, it's really simple. What'd you do to 5? Added 1. What'd you do to 33? We added 1. What did we do to 1,172? We added 1. The next number after n in counting would be n plus 1. How did I do that? I added 1 to n. What number would be after that? Well, n plus 2. Here's a good question. What number would be before n? Well, what number is before 5? 4. How do you get there? We subtract 1 because we're going backwards. 32 comes before 33. How do we get there? We subtract 1. So the number before n must be n minus 1. All right, we have to think about variables in that way. Now that we've done that, we're going to go take a look at some patterns. We're going to start off with a baby step one and see if we can't develop a way to do the more difficult problems. All right, my first sequence of numbers is this 1, 2, 3, 4, 5 on forever. Now I'm going to find the nth term, which is here on my table, the 20th term, and the 90th term. Now I know most of you can probably just tell me those answers right away, but we're going to use this baby step example to help us do harder problems. Now, by the way, what all kids like to do a lot of times is just make their table right here through the sequence, and you feel free to do that. I'm not going to do that because it looks kind of sloppy, so I made up this table here ahead of time. All right, the first thing I'm going to do is I'm going to copy 1, 2, 3, 4, 5 in. The first term is 1, the second term is 2, third term is 3, 4, 5. Now I'm searching for the nth term. I'm going to come down here and I'm going to find my first difference. In other words, I'm going to find the differences between the 1 and 2. Well, I add 1. The next difference, add 1. The next difference, add 1. Next difference, add 1. By the way, difference means subtract, right? 5 minus 4 is 1. 4 minus 3 is 1. 3 minus 2 is 1. You notice how that plus 1 shows up every single time? That means that I am going to take plus 1 and multiply it by n. This will get me the nth term. And positive 1 times n is simply 1n, or better yet, just plain old n. So my nth term is n. It won't always be that way. This is just a baby step example. All right, now to get the 20th and 90th terms, all I'm going to do is plug 20 in for n. Well, if n is 20, then my answer is 20. If n is 90, my answer is 90. Okay, let's look at one that's easy but not quite as simple. I've got the numbers negative 4, negative 3, negative 2, negative 1, 0. This is the first term, so I write it in box 1 of my chart. Next term, next term, next term, and next term. Again, I go to find the first difference. Well, it's looking like it's going to be plus 1, plus 1, plus 1, plus 1. So it looks like my nth term will be something like plus 1 times n, or better yet, just plain old n. And I'm going to write that in purple because in this case, it's not going to be exactly that. So I'm guessing that my pattern might be n. Now, I'm going to test it. I didn't test on the last one because I'm kind of cheating. It was so simple. I'm going to fill in these purple blanks. I'm going to put 1 in for n and get 1. I'll put 2 in for n, get 2, 3 in for n, get 3, 4 in for n, 5 in for n. And now I'm going to compare them. How do I turn 1 into negative 4? Well, I subtract 5. How do I turn 2 into negative 3? I subtract 5. How do I turn 4 into negative 1? I subtract 5. How do I turn 5 into 0? Subtract 5. You see how if my answer were n, I'd have to subtract 5. That means my nth term is going to be this n, but then I have to take 5 away from it. See that? Minus 5 every single time. So to get the 20th term, I'm going to do 20 minus 5, which is 15. To get the 90th term, I'll do 90 minus 5, which is 85. All right, now the difference isn't always going to be plus 1. Let's look at this one. First thing I'll do, the first term is 2, second term is 4, the third term is 6, the eighth term is 4, the fourth term is 8, and the fifth term is 10. Again, I go looking for the first difference. Okay, it looks like I got plus 2, plus 2, plus 2, plus 2. That means that I'm going to have a plus 2n, or better yet, just 2n. Now again, I still have to compare. If my 2n pattern matches the blue numbers, then I know I've got the right formula and I can stop. So I'm going to take this 1 and I'm going to put it in for n right there. So in other words, this number here is going to be 2 times 1, which is 2. This will be 2 times 2, which is 4. Hopefully you can do most of this in your head. I'm just showing it to you because it's probably new. 3 will be 2 times 3, which is 6. 2 times 4, which is 8. And 2 times 5 is 10. The purple ones match the blue ones perfectly, don't they? They sure do. So my answer is going to be 2n. To get the 20th, I'll do 2 times 20, get 40. 90th, 2 times 90, get 180. All right, let's look at one that's not so simple. Again, I'll copy in my values. Okay, so I go looking for my first differences again. Looks like it's plus 2, plus 2, plus 2, and plus 2. So I know my answer is going to be something like 2 times n, or better yet, just 2n. I'll check. And, you can't just check one. You have to check at least three. You check two, you'll be right about 70% of the time. Check three, you'll be right about 95% of the time. If you check all five, you'll be right every single time. All right. So I'm going to take one and I'm going to put it in for two. In for n. 2 times 1, 2. 2 times 2, 4. 2 times 3, 6, 8, and 10. Now I compare. How do I turn the purple one into the blue one? I add 1. How do I turn that? I add 1. Turn that one, add 1. Add 1, and add 1. That means that my nth term must be 2n plus 1. All right, now I can stick 20 in for n. 2 times 20 is 40, plus 1 is 41. 90 be 180, plus 1, 181. That's how simple this is. One more example. All right, I've already filled in a chart on this one. Again, I'm looking for the first difference. Plus 4, plus 4, plus 4, plus 4. My answer has to be something like 4n. I'll test it and see if they're all off by the same amount. 4 times 1, 4. 4 times 2 is 8. 4 times 3 is 12, 16, and 20. And then ask myself, how do I turn the purple into the blue? Looks like I'm subtracting 2 there. Minus 2, minus 2, minus 2, and minus 2. What do I need to do to 4n? I need to subtract 2, 4n minus 2. Now, the 20th term, I'm going to do 4 times 20 minus 2, which I think will be 78. The 90th term, I'll do 4 times 90 minus 2, 360, 358. And there we go. I am done. Give myself a great big blue star. Yay! All right. Tomorrow we'll do a couple formative assessments. Those of you get this right away, we'll get started on the homework. Those of you aren't sure, we'll get a little more practice in class before you get to the homework. All right, Mr. Lawrence signing off. Have a good night, everybody.